Welcome back, guys. In this video we'll be taking a look at special angles under trigonometry. Now we have three special angles in the first quadrant. Now subsequent video we'll be doing the fourth quadrant. We have three special angles in our first quadrant. That's your 45 degrees, then you have your 30 degrees and your 60 degrees. Now, to get the value for your sin 45, cos 45, and tan 45, we'll make use of an isosceles right angle triangle. Isosceles triangle means that two sides are the same. A right angle triangle meaning that one of the angle here is 90 degrees. Now, since we know that two sides are the same, so I can boldly say that let here have a unit of 1, that's 1 cm, 1 meter as the case may be. Let here also have a unit of 1. So if here is having a unit of 1 and here is having a unit of 1, making it an isosceles triangle, this is 45 degrees, this is 45 degrees. Obviously, base angles has to be the same. So here has to be x. So if we solve for x using your Pythagoras theorem, your x squared will be equal to 1 squared plus 1 squared. So x squared is equal to 1 plus 1. X squared is equal to 2. So x is square root of 2. So I can put it here that x is equal to square root of 2. Now we can boldly get our sin 45, cos 45, and tan 45. We can make use of this angle. We can also make use of this angle to give us exactly the same thing. Now let's make use of this angle. So my sin 45 is equal to opposite over hypotenuse 1 over root 2, which can also be written as root 2 over 2. My cos 45 degrees is equal to adjacent over hypotenuse 1 over root 2, which can also be written as root 2 over 2. Lastly, we have tan 45 degrees. Tan 45 degrees is opposite over adjacent, which is 1 over 1, which is equal to 1. So these are the value of sin 45, cos 45, and tan 45. Similarly, for 30 degrees and 60 degrees, we'll make use of an equilateral triangle. That is a triangle in which all the angles are the same and all the sides are the same. Now, for convenience, let's name here to be 2 units, 2 units, and 2 units. You can put anything. It can be 1, 1, 1. It can be 3, 3, and 3. You get exactly the same answer. But 2 will do it easily for us. Now that I know that this is 2, 2, and 2, now let's divide here, or let's bisect this triangle. That's dividing it into 2 equal parts. So I'll divide here into 2 equal parts. So let's take one of the parts away from there. So one of the parts is simply something like this. From here to here is 2. I bisected it, so here has to be 1. This was obviously 2 from the onset. Then this angle here is 60 degrees. Now it is obvious that this is an horizontal line and a vertical line, so these are perpendicular. So the angle here should be 90 degrees. So I have an angle of 90 degrees here. Now I'm bisecting this angle here, so this guy here should be 30 degrees. Here is 1, here is 2. Let's call here y. Using your Pythagoras theorem, I can write that y squared plus 1 squared is equal to 2 squared. So y squared plus 1 is equal to 4. Y squared is equal to 3. Y is equal to root 3. So I can put here in place of y, this is root 3. Now I can find my sin 30 cos 30 tan 30. Also sin 60 cos 30. I make sin 60 cos 60 and tan 60. So let's start with 30 degrees. Sin 30 degrees opposite hypotenuse. So you have 1 over 2 cos 30 degrees adjacent hypotenuse root 3 over 2 tan 30 degrees opposite adjacent 1 over root 3, which is equal to root 3 over 3. Now for 60, we have our sin 60 degrees to be equals to opposite hypotenuse root 3 over 2. Cos 60 degrees is equal to adjacent hypotenuse 1 over 2, and tan 60 degrees is equal to opposite adjacent, which is root 3 over 1, which is equal to root 3. So these are the values of the special angles 45 degrees, 30 degrees, and 60 degrees. Now if you enjoyed the video, kindly use the like button and don't hesitate to subscribe if you are yet to do so. See you guys in my next video.